Today I will talk about the topic marine calcifiers exhibit mixed responses to CO2-induced ocean acidification. Introduction. Surface ocean pH has decreased by 0.1 unit since the industrial revolution, and with the more anthropogenic CO2. We know that more CO2 will make the ocean more acidic, and the carbonate in the seawater combine easily with hydrogen ion. Let's make a reduction in calcium carbonate, and make an impact on marine calcification. So I will show you how the marine calcifiers respond to the elevated CO2, and we will observe the various response between them, which is more complex than our thought. Method to observe the impact of ocean acidification on a range of benthic marine calcifiers. We feed 18 calcifying species for 60 days, such as temperate corals, pencil urchins, and so on. And we put them in 25 degrees Celsius experimental seawaters with 4 average pressure of CO2. And the sum of them is the average seawater saturation with respect to organite. Organite is a form of calcium carbonate. The relationship between them is just like carbon and the diamond. Result: the latter features are made up of the experimental results, and we see one of them. The x-axis is saturation of organite. The y-axis is net calcification rate. Calcification rate is the total calcification minus the total dissolution. If the value is positive, it's calcification, and the value is negative, it's dissolution. And we can conclude some other trends how the 18 organisms respond to the elevated CO2. And from the following part, we can ignore what the organisms what they are. We just focus on the trends. 10 of them. The net calcification decreases when the pressure of CO2 increases. And the 6 of the upper 10 shows dissolution in the highest pressure of CO2. And the 4 of them in the intermediate pressures, they shows increasing, and in the highest pressure, they shows decreasing. And the 3 of them, net calcification is greatest on the highest pressures, like this. And one of them shows no response under the change of the pressures. And discussion. The following part is the factors explaining variable responses among organisms. First, many calcifying organisms produce calcium carbonate by reduction in the hydrogen ion at the site of calcification. And this localized increase in pH can finish by various proton regulation. And however, some organisms maintain an elevated pH at their site of calcification, despite the reduced internal pH. If seawater is the source of organisms' calcifying fluid, the dissolved inorganic carbon will increase when the pressure increase, and they will directly convert the DIC as hydrogen carbonate ion to carbonate. And the second, most of organisms produce external organic layer to separate shell or skeleton from surrounding seawater, just like our skin. And see the figure in the left. There are species totally covered by organic layer, and the right one is largely composed to the surrounding seawater. And we can notice that the left part is shows great calcification than the right part, and we can make the conclusion. Third, Oragonite and the high manganese calcite are the common forms of the more soluble calcium carbonate, and their six species exhibit dissolution. Among them, four of them are composed of oragonite, and one is composed of high magnesium calcite. And we can observe organisms utilizing the more soluble forms will be more adversely affected by the elevated CO2. And fourth, there are three species utilize CO2 via photosynthesis, and the left two parts they are directly utilizing the CO2, and the right one which contains symbiotic algae is whose photosynthetic products are sent to the coral, and this means the coral doesn't utilize the CO2 directly, and it shows no response over the range. We can notice whether direct utilization of CO2 via photosynthesis may make an influence. Conclusion. As I mentioned, As I mentioned above, we can get these four mainly affecting factors, but the response of marine calcifier is complex, and with the data at hand, it's difficult to predict how these changes in classification will impact organisms, and we will keep generating the data. Thanks for your attention.
Okay, 11 minutes. QA. Win. CK. Tony. Irene. Sylvia. Okay. Starting with Wayne.
How do you choose too many species, a lot of few species to do the experiment?
Repeat.
Why do you choose many species, but not just a few species to do the experiment? That can be more easy. Why don't you just choose a few animals to do the test?
Why do I choose more animals to do the experiment?
The other way around. Why don't you choose less animals? Maybe 5 animals or 5 species, not 18 species.
I think less animals cannot observe the result. Yes.
Okay, move on. CK.
What is your point to make you present this?
Purpose.
Yes, this.
Because when I read the title of the paper, I'm interested with it. Yes.
Move on. Tony.
You say the seawater pH is decreased 0.1. How do you know?
How do you know? The paper has the data before, and he write it down in the introduction.
All right. Move on. Irene.
How do you choose these 4
Because these 4 degrees represent the range of values predict for the coming mediums.
Is that your question? Can you repeat your question again?
What is 4 number? Why you choose these 4 numbers?
These 4. Because the writer choose the 4 is to represent represent the range of values predict for the coming millions.
Okay, coming millennium.
Yeah.
Okay, millennium. Okay, Sylvia.
How do you calculate the net classification? How do you calculate the net classification?
Repeat.
How do I
Calculate.
take the net classification? The net classification is estimated from the changes in their volume weight. In Chinese is 浮力. The change.
Volunteer question, Annie. I will choose those haven't. 1, 2, 2 girls, 3, 4. Okay, 1. What's your name?
Benson.
Okay.
Go back to the figures. Can you explain what is the gray area means? What is the gray area means? Standard deviation.
What is gray
Area.
area?
Area.
Other figures. Yes.
The paper not mention about it, but I think that is the plus or minus their by plus or minus their standard deviation.
Paper must have mentioned it. Who is the next? What's your name? Okay, William.
Is now of over organic in our format. What is over
This means the CO2 which is emissions which is made by the people.
Alright. Who is the third? What's your name?
Becky,
Becky, okay.
can you explain what is the polymorph?
Polymorph is substance composed of a chemical has various forms in the different conditions.
Okay, it sounds like it's not explained. Okay. You are. Okay.
In your method and materials, how do you collect your data, the solution? How do I collect your data?
Can you say that again?
In your method and materials, you didn't mention how you collect the dissolution. I didn't know how you collect your data. How do you collect the data to represent the error line?
How do I collect the data?
Right.
Sorry, I didn't know well in the paper.
Alright. My turn. Because it's a chemistry paper, so you have to be aware that it's in general more difficult for the audience to understand, even if you have explained it. For example, polymorph morphology, mineralogy, you have in a way explained it, but it's not clear. All right. So first of all, below other terms, you need to explain next time better. First of all, what is here? Where? Like this, the horizontal line is right? Mostly omega aragonite. That reads omega, this guy. And you need to explain us, what does this mean? There's a meaning. You say, it corresponds to different CO2 concentration. But there's a meaning for that. For example, at 1, when the value is 1.0, what does that mean? Okay, you need to explain us better next time. Second, that would correspond to their question, the polymorph mineralogy. You probably need to find a way to better explain the, I don't know where to find it. You find a way to better explain it. How to explain polymorph mineralogy. Okay? Okay, so these are the two terms that you need to explain better. And then another thing that I think is missing, but I would say it's a little bit important, is you sort of ignore the identity of these creatures. Like you did not really explain. For example, I really don't know what's that. What's that? What's that? I don't know. I don't even have a picture in my mind. So I would say it would be just a piece of cake to Google it and use images, paste here, so we know what is what, who is who. Okay, because later on during your discussion, at the beginning you say, let's don't look at which species they are and just look at the pattern. That's fine. But then when you start to talk about why there are interspecies variation of the pattern, you start to talk about their biological effects. Like some of them have external organic layer, some of them not. And then at that time, I think that would be the right time for you to maybe just use a photo to tell us. And actually, I don't even know, lobster, do they calcify? I don't even know that. So, 龙虾会造钙吗？对. Okay, I don't know, maybe they do. So, I think spend some time to talk about who they are. That should be done. Because later on you talk about why there are so many differences. Okay. And another thing that came out twice during the QA is, how do you obtain the data? Okay, so in this is actually the only main result, in my opinion. And here you say, this is a net calcification where you have an equation. Where is that? Here. Net calcification rate is this minus this, which means you need to measure this and this. Or do you just measure this? I don't know. Okay. That's the reason why Stella asks, do you measure dissolution? Do you? Or you just measure their buoyant weight and that means this? You need to figure that out. Yeah. Okay. And then at some point, I think the paper itself is sort of easy, but still it would be great to, when you are presenting these slides, you actually read some script, read something, You say something, then you should print that down here. What did you say? Because that's your research goal. Do not use this. There's a figure here. I don't know. Oh, there's no figure here. So you should print down what's your research goal here, clearly. Okay. So, but there's still some strength about this talk. I think there's something that you can learn from her talk would be, she has a quite lengthy discussion, but during her discussion, she managed to link her discussion back to her data, like here. Okay, protective external organic matter layer, where you can see that, etc., etc. So she tried to link her discussion back to her data. And very often she used arrows to represent going up, going down. That's also easier to follow. But I think because it's chemistry, so you really need to spend some time to explain this basic term, because this is not something you can just use an image and then everybody understand what's that. That's the problem of chemistry talk. So you need to explain maybe some equation. Okay, and there are some pronunciation problems, like algae, organism, calcification. So next time, try to practice more often so you can pronounce them well and fluently. Okay, so let's thank Lina.